Right, we are now officially live, and I would like to welcome our very special guest. We have Dr. Lori Glaze, who is the director of NASA's Science Mission Directorate's Planetary Science Division. And of course, with it comes many other accolades and titles under her belt, but we were going to try and dig into all of those things as we go through this interview. But of course, I am representing the Humans to Mars Summit, which is coming up from the 16th to the 18th of May. And it is our job to try and spread the joy of STEM, but in particular space. And what we are hoping to do is to learn a little bit more about Mars, learn a little bit more about the planets, maybe some exoplanets. You might know some stuff about those things. So to begin with, how did you get to become a sciencey, spacey person?
A sciencey, spacey person. Well, I was always really, really interested mainly in math. I liked science too, but I was really into math. I loved math so much. And so when I was in high school, I took a lot of math and science classes. And then when I went to college, I started taking physics classes and a lot of higher level math classes. And when I realized how math and physics fit together, that so many of the math classes that I liked were invented in order to help us do physics, that got me really excited. So that's how I got started in science in general. And then as I was going through and getting my college degree in physics, I discovered volcanoes. And I had always been interested in volcanoes, but that got me very excited. And I did all of my graduate level work, taking my math and science background and applying those to helping us better understand how volcanoes work.
Aha, so you are a volcanologist.
Correct.
Have you ever been to a volcano before?
I've been to lots of volcanoes. My background as a physics and math person meant that a lot of my work was working on a computer, but I worked really closely with geologists and volcanologists that work in the field. And it was important to go see the things I was trying to model. So I spent time at the volcanoes in Hawaii that were actively erupting. I've been to volcanoes in Chile. I've been to volcanoes in Italy. I've been to volcanoes in Russia. On the Kamchatka Peninsula. So lots of different volcanoes, very exciting.
Did you have to wear those special silver suits?
No, the places where I went were either the volcanoes in Italy and Chile and Russia were not actively erupting, and so those were pretty safe environments. The one in Hawaii was actively erupting, but very kind of a slow and calm kind of eruption, what we call a pahoehoe, which means it's just these little small blobs of lava coming out. Moves very, you could probably crawl faster than the lava flow comes out. So it was a very safe environment.
Sure. Well, I think that in itself is a whole interview I could chat about. But then, of course, you moved on from volcanoes. How did you get into the space world?
That's a great question, because I started out, I was interested in volcanoes on Earth. I actually, one of the reasons I got interested was I lived in Washington State when Mount St. Helens erupted. And so that got me excited. And so I was really interested in volcanoes on Earth. And then I got my first job at the Jet Propulsion Laboratory in California. And JPL builds a lot of the planetary spacecraft missions for NASA. And so I got interested in learning what they were doing, but I also, while I was there, started learning a lot more about the planets in our own solar system and learned that Mars is covered in volcanoes. Venus is really covered in lots of volcanoes with lots of volcanic deposits on the surface. And there was there's been a question for a long time, is Venus actually still volcanically active, just like Earth? And so that got me very excited. And that was really what drove me to kind of shift from looking at Earth to looking at volcanoes on other planets.
So you never started off being a space fan. I mean, you weren't against it, but I mean, it wasn't something that you said, when I finish school, I'm going into space.
I've always, been a fan of space. I love space, but like you say, it wasn't something that I knew. Many of my colleagues say, I remember, the man, Neil Armstrong landing on the moon, and that I decided at that moment that I was going to go into space science or engineering to support space science. And I was pretty young at the time Neil Armstrong stepped on the moon. So if I was watching it, I don't remember. But I was still a fan of space science. I just didn't have that. I didn't know at an early age that's where I was going to end up. Sometimes it's a random path, right?
Well, it's serendipity. I mean, it was bound to happen. It just, when the stars align, speaking metaphorically, of course, these things just, your path is revealed to you. So now you go to JPL, you're spending a little bit of time there, you're learning about the planets, and obviously they are building crafts to go and visit some of these planets. Which projects were you involved with?
So while I was there, I wasn't actually working on any of these, but at the time I was there, Voyager was flying past Neptune. That was amazing. That was really incredible. They were in the process of building the missions, Galileo, that was going to explore Jupiter, and building the Cassini mission that was going to fly to Saturn. The Magellan mission had just been launched to fly to Venus. And so that was another thing that was very exciting. Got me very interested in Venus science as well. I actually went out there to work on an idea for a mission called the Orbiting Volcano Observatory that would be an Earth orbiting observatory. So as I said, I started looking at Earth things, and that's why I went out there. That was the main project I was on while I was there.
Whew. Okay, so then you moved on from JPL?
Mm-hmm. I did. So a lot of my story about where I ended up where I am today has to do with people that I met and started working with that kind of guided my path. And while I was at JPL, I started working with a planetary scientist who did a lot of physics and modeling like I did. And he had started his own company called Proximy Research, and it was a little tiny company, and he convinced me to come work for him there, and we did science research for NASA for 11 years, being able to write our own science grants and do a lot of the science research that we wanted to do, and that was amazing. I wasn't working on flight projects or missions, but while I was doing that, I still had a lot of colleagues, especially some colleagues at NASA's Goddard Space Flight Center in Maryland, the US. And while doing my work at Proximy, I started working with these scientists at Goddard and started working on mission concepts we did a proposal for a Mars mission, and we started working on Venus mission concepts. So we worked on a bunch of those, and ultimately I ended up taking a job at Goddard to work on several of those Venus mission concepts.
Can you tell us a little bit about some of those Venus mission concepts?
Sure. So some of the ideas we were working on, we started thinking about trying to get to Venus because the United States hadn't been to Venus since 1990. It was a long time to not have a US mission to Venus. And so I started working with colleagues on an idea to send, first we were thinking about an orbiter that would carry a radar, could see through the thick clouds on Venus. The clouds are 15 miles thick. So you got to be able to see through those with radar. And then it would carry what we call a probe, which is just a sphere. It's about 1 meter around that would dive down into the atmosphere and measure what all the gases are in the atmosphere. And so we did that mission, and then we had another chance where we split those apart and we proposed those separately, the orbiter and the probe. And then finally, we put one in with just the probe, and we called it Da Vinci, which was a mission. So I got to be the principal investigator of that mission. And it was a cool mission, as I said, the probe to go down in the atmosphere, measure the gases that are there. We almost got selected, but not quite, while I was the principal investigator. And then when I came to NASA headquarters, my colleague, Jim Garvin, he and I had been working on all these concepts for a long, long time. He took over as the PI, and now it's finally selected. And so
how long does it take to get to Venus?
interesting to get to Venus. Venus is the closest thing to Earth other than the moon, the closest thing to Earth in our solar system. The fastest we can get there with the rockets we have today is about 5 months.
That's not so bad.
Not so bad.
But that depends where Venus is at the time that it's going around the sun.
Yes, so we try and find the time we can launch that takes the least energy. So that's the least energy launch is the 5-month cruise, 5-month trajectory. The Da Vinci mission actually does a flyby of Venus to give it a little boost, and then it comes back around to get it in the right orientation to drop off the probe. So it takes a little longer than 5 months, but.
And that probe is on a one-way mission?
It would be one way. It is not coming back. I don't know how much everybody knows about Venus. I already said it has 15 miles of clouds in the atmosphere, and those clouds are made of sulfuric acid. So that's kind of crazy just to start with. And then you go through the atmosphere. It's mostly carbon dioxide, but it's so thick, the atmosphere, that by the time you get to the surface, the temperatures are hot enough to melt lead. It is so hot. And also the weight of the atmosphere is like being a kilometer underwater. If you could imagine when you dive down to the bottom of the pool and your ears want to pop, that's only a few feet of water or a couple of meters. But if you were to go down a full kilometer underwater, that's how heavy the atmosphere is on Venus. So once you send a probe down into that hot, high pressure environment, it's not coming back.
So how much information can you glean from a probe like that, and what is the lifespan of the probe once it's been launched?
So once it leaves the spacecraft and comes into the top of the atmosphere, it takes about 1 hour for it to fall through the atmosphere. It kind of falls like, if you can think about a rock settling on the bottom of the ocean, it's kind of like that. So it takes about an hour for it to fall all the way through the atmosphere. So it has to be thinking fast and collecting the data and sending it back up as fast as it can, because once it touches the ground, it may last only another 15 minutes or so before it gets too hot.
Wow. So a lot of it is all theoretical because you don't know how long it's going to last. And where do you even do testing for a device like that? I mean, it's not like you've got buckets of, well, I suppose you could pour buckets of sulfuric acid all over it just to see what it would do. But in terms of the materials that you're going to use to preserve it, how does one test that?
That is a fantastic question and one of the biggest challenges. So we actually have built, or will be building, at Goddard Space Flight Center, a special facility just for testing that probe, that sphere, so they can test it and make sure all the seals are going to hold. They'll test the system inside that will help keep the temperature a nice temperature for all the instruments inside for that time, that 1 hour. But it's a very special facility that can allow not just the temperature and the pressure, but also the carbon dioxide, which can be corrosive on the material. So they expect to build it out of titanium, which is pretty durable and lightweight. So that's the plan.
Sure. I mean, and when are they expecting to launch?
Right now, Da Vinci is working on a schedule to launch in 2029.
That's not so far away.
It's not that far away.
So do you kind of still have a pinky involved in it? Does Jim kind of call you up and say, listen, we are having a bit of a launch party. You kind of were involved.
They keep me pretty well informed, but it's their mission. My job is to oversee all of the missions in our division on planetary science at NASA. And so I look after Da Vinci, I look after our other Venus missions, Veritas. We have a mission we're doing with ESA, with our European Space Agency, called Envision. So I get to oversee all of those Venus missions and all of the other missions in our portfolio. But
of course, Venus is not the only planet in our solar system. And since we're chatting with regards to the Humans to Mars Summit, Mars is certainly on our radar. It is something that we definitely want to reach, but we're going to the moon first. What are your thoughts on that?
I'm so excited about getting back to the moon. Just this week, the first 4 astronauts that are going to launch on Artemis 2 were announced. That's very exciting. That crew includes a Canadian, 3 US astronauts, and of the 3 US astronauts, we have the first woman and the first person of color to go to the moon beyond Earth orbit. So that's very exciting. In addition to the humans going to the moon, we have a really exciting robotic program. These are our space robots. That's what I'm responsible for, that are going to be flying to the moon in advance of humans landing on the moon. So we actually have partnerships with a bunch of commercial companies where we're sending our science instruments to the surface. They're bringing their own payloads, but we get to have a ride with them. And the first 2 of those are supposed to launch this summer. So we are really, really excited.
What are those robots going to do?
So these are going to land, hopefully softly, on the moon. And as I said, they're carrying our instruments. Our instruments are going to be doing things like measuring the composition of the atmosphere, looking at the surface, and things like that. These early landers, these first ones that we're sending, only have to live for a couple of weeks. They don't have to survive very long. But they'll be carrying some of their own payloads. One of them that's going to launch, I believe, is carrying a little tiny rover from Carnegie Mellon University, as well as a bunch of other little payloads that other people have asked them to carry. So it's a real interesting new experiment, a new way to explore.
Now, it's very interesting that you say that, because you intimated that it's not just a case of we're landing a rover, we're also including experiments from certain universities. And that brings me to, obviously, the commercial investment in space. As I don't need to convince you that the space world is growing at an exponential rate, kind of like the speed of the universe. But the point is that a lot more people want to get involved. Doesn't it get complicated when you're bringing other people's toys into the play pit?
Well, that's why we've set up our program the way we have. It's called the Commercial Lunar Payload Services Program. And what that means is these aren't NASA missions. They're not our missions. The first 2, one is being led by a company called Astrobotic. Another one's going to be led by a company called Intuitive Machines. It's their mission. So Astrobotic has their own mission, and so they can sell off space on their lander to anybody they like, and Intuitive Machines, they sell off space on their lander to anybody they like. And then we say, can we fly some of ours? And we want so much mass and so much capability. You need to keep our instruments at this temperature. You need to be able to send our data back, but it's their mission. It's not our mission. So we get a ride, we get our science, and these companies are building new capabilities to land on the moon and provide access to the moon for such a broad swath of the global community.
But now, we got to the moon back in the 60s, and now we're going back again now. Some have tried to get to the moon in the past few years, and some were a little bit more successful than others. Why is it so difficult just to get to the moon? I thought we had that under the wraps.
Well, I will say nothing in space exploration is easy. Everything is challenging, and being able to make sure that you've got all of your hardware systems, your instruments, and your software that controls the landing, making sure all of that is working perfectly is really, really challenging. And I think the last few years have really demonstrated just how challenging it is. As you say, there have been a couple attempts that were not successful in the last couple of years. But I know they're all trying again. I know many of those countries that or organizations that tried to land previously are working on new landers. And all of these new commercial companies are thinking about landing. Now, again, this is kind of an experiment. They've never done it before. We don't expect every one of them to land softly, is what I say. I don't say failure, because I think we're going to learn something and be successful no matter what happens, but they may not all land softly. But the point is, we now have, I think, 9 of these missions already planned. We've got our instruments that are going to fly. We're helping make sure that these companies have a steady stream of opportunities to fly to the moon. And I think on the whole, they're going to get more practice and get better at this. And we're going to have so much more opportunities to get to the moon with all these commercial companies.
Is there a body that determines who's coming, who's going? Because I mean, I could decide tomorrow I'm launching to the moon. Who do I need to consult? I mean, NASA's not the only person that is, or the only organization that's running things. I mean, it's not like you have a boss. So do you have like an agreement that is, I don't know, I haven't heard of an agreement yet. Is there one?
Well, we do have general international agreements under the United Nations on the peaceful use of outer space, which kind of governs overall how we all try to play nice with each other as we explore beyond Earth. But other than that, like you say, if a company wants to fly to the moon from the United States, they have to get approval from the Federal Aviation, Aeronautics and Aviation, FAA. What's FAA? From the FAA here in the US, they have to get that permission in order to launch. They are expected to abide by some of the guidelines that we have from another a group that's under the auspices of the United Nations called COSPAR, that provides guidelines for saying, if you're going to fly to the moon, please tell us what you brought. Please tell us what chemicals you're bringing so that if we ever measure something there, we know what was brought by humans and what may have been delivered from some other way. So we want to know what the fuel is made of and things like that. We want to know what's on board, but people don't necessarily have to report. It's the best practices and the guidelines to let the rest of the world know what was brought. But like you say, there's no governing body there.
Oh, space law is going to be a very exciting career, Brian. I know Brian's definitely into space law, so that's something he'll be pursuing. And your gut feel, do you think we will have hotels on the moon and we'll be able to go and visit the moon?
Oh, I hope we'll be able to go visit the moon. I'm not so sure about hotels yet, but who knows? I think, 50 years ago, when the astronauts were first taking their steps on the moon, I don't think we even could envision the types of missions we have now, such as Perseverance, that's called, exploring Mars, and we're going to bring samples back from Mars. It was hard to even imagine we could do that. So who knows where we'll be in 50 years? I think all of your young people here on this, listening to us today, they're the ones that are going to be building those hotels. So that's exciting stuff.
I hope you're going to save a room for us. But now you mentioned sample returns. I mean, we've been to Mars a few times. It's not our first rodeo. Some of the rovers are still doing their thing. They've been there for a couple of years. Perseverance in particular has been very interesting because it brought a little bit of extra luggage with it in the shape of a drone that has been looking at things from a different perspective. When I tell people that we've got a rover on Mars, it's only looking at a tiny section of Mars. So we don't really know what is all over Mars, but just the section that it's observing. The drone can maybe see a little bit further, but what sort of size land would you say that this drone has actually managed to explore? Maybe a few hundred hectares, if that?
Gosh, if that. I know, let's see, the helicopter the helicopter is named Ingenuity and the rover's called Perseverance. We call them Percy and Jenny. And Percy and Jenny have traveled now a little over 17 kilometers linear distance. And so the helicopter's done a little bit more than that, of course, flying around and exploring other areas near to the rover. But yes, not a large area, but keep in mind, we have a whole fleet of orbiting satellites at Mars that have done global imaging and high resolution images. And so the best thing about having these rovers and the helicopter on the surface of Mars is they can go and look at a place that we saw from space and say, well, we think this is what's there. They can go down there and actually look at it up close and measure and take samples. And that helps us kind of do a a ground check or a check of the information of the data from space, that helps us better interpret all the data for the whole planet, to better understand what we're seeing in those remote sensing, the images from space.
And what are we looking for on Mars? I mean, are we just looking for life? Are we looking for an alternative spot to move to? What is our purpose behind Mars?
So there's a lot of really good reasons to explore Mars. And yes, life is one of them, because certainly we think that in the distant past, maybe 3.5 billion years ago, in the early days of Mars, we believe that it was much warmer and wetter than it is today. Today, it's very dry and cold. But in the past, we believe it was warmer and wetter, and that possibly it may have had the right conditions there for life to just get started, kind of like on Earth, where in those early days, you have water, you've got solar energy, you've got the nutrients from volcanoes putting gases into the air and the rocks in the soil. So it's possible that way in the way back there, early microbes may have started to take form on Mars. So that's one of the things that we are looking for. But in addition to that, on Earth, we can't see back 3.5 or 4 billion years because of plate tectonics and recycling of the crust and erosion from all of the wind and rain and weather that we have here, and ice. Just, kind of continuously modifying what the surface of the Earth looks like. So if we want to know what a rocky planet was like in that early time, Mars is a great place to go and see what rocky planets were like, because that's been now preserved. It's been kind of frozen in time there for all this time, for 3.5 billion years. You can go back and see some of these surfaces that are really, really old. We've only got a couple places on Earth that are that old. They're not very many. So that's another great reason to study Mars. And then just understanding various planetary climates. You talked at the beginning about understanding exoplanets. So being able to understand how Mars's climate has changed over time, and looking at Earth's climate over time and Venus's climate over time, helps us be better informed about how to look at planets around other stars to know, are they perhaps Earth-like or more Venus-like or more Mars-like, or, as a planet evolves over time, is it on an Earth trajectory, or Earth path, or a Venus path, or a Mars path? So Mars is a great place to go where we know how to survive on the surface for a long time. Curiosity's been there over 10 years. It's a great place to do all kinds of great science.
Do you think robots do better science than humans?
I don't think it's better. I think they're highly complementary. I think humans have the best computer ever invented in our brains. The connection of our eyes and our senses and our brain can compute so much faster than we can still with our robotic computers. We can look over an area and integrate quickly and identify, this is the sample I want to take, or that's the area I want to go explore. We're really, really good at that. And we can do that very efficiently. But we have needs. We need oxygen, we need water, we need sleep, we need lots of things that are hard to do in other environments. Whereas a robotic explorer, it needs a little sleep, it needs a little sunshine for power, or sometimes it's got a nuclear battery, so it doesn't need sunshine. But they can operate for long periods of time where humans perhaps can't. And so that's why I think bringing them together, we work together, use the robots for what they're good at. They can go off and traverse long distances and come back, and we can work together. I think we're going to work together really well with human exploration.
And of course, the big prize is to see if there is life on another planet. So we're digging in the soil, we're bringing back samples. I don't know when those samples are expected to return, but when I spoke to the representative from ESA, still a few more years to go.
Yes.
But at the end of the day, are we looking in the right place for samples of life, or are we just looking at general samples?
So that is a great question, because where we sent Perseverance is a really special place, and we picked it specifically because we think if we had those right conditions for life 3.5 billion years ago, this is where it would be. And if it's not there, that's going to tell us something too. Where we went is a place called Jezero Crater. It's a big, giant impact crater where a meteor hit Mars and left this big hole in the ground. But then after that big hole in the ground, there was clearly a lot of water on Mars. You can see the evidence for a river flowing into that crater, and it must have flowed into a big lake, a big standing body of water, because you can see as the river came in, it dropped the sediment, the mud and the sand and the dirt and the rocks. It dropped it and formed this big giant, what we call an alluvial fan, a big fan. It looks a lot like the Mississippi River Delta, if you ever see what that looks like in the Gulf of Mexico or other places around the world. And so we know that if that water was there and we had the ingredients for life, that river would have been bringing material from a huge area outside of the crater and dropping it all right there, right and in that lake bed. So if there were these early microbes on Mars, that's where they'd be, in this river delta on this lake bed. And so those are the samples that we're collecting. We're collecting geologic samples to help us better understand the climate at the time, to better understand the age of the crater more precisely, and then specifically going after these mudstones and sandstones from the river delta.
If you were a betting person and those samples came back, what are the odds that they might find some teeny tiny little microbe, something to prove? I mean, it could be a fossilized microbe, because it's certainly not going to be alive. What do you think the chances are they're going to find something in there and everyone's going to go, we knew it. There we go. We are not alone.
Well, so that's a two-part question. So I think there's a fairly reasonable probability that there's something in there that could indicate life was present in the past. These early microbes from ancient times, fossilized microbes. We don't really think there's a chance there'll be something actually alive there today. The conditions are not very good for that. But being able to instantly recognize it and go, haha, we told you it was so, is probably pretty small. These types of measurements and ability to identify something that is alive or was alive is really hard. And so I expect it's going to take a lot of scientists and a lot of debate and discussion about, is this or isn't this actually evidence of something that was alive in the past, which is kind of how our science process works. So I don't expect it to be a super obvious, but I know that our scientists will work on it, and the scientists around the world will keep looking at those samples, not just as soon as they come back, but decades to come. And we may have new ideas of how to look at them in the future, and we'll get those questions answered.
Who gets those samples first?
Well, the mission itself, the Mars Sample Return mission, is a joint collaboration between European Space Agency and NASA. And so when those samples are first returned, there will be a team of scientists, primarily European Space Agency and US scientists, but it will be an international team. So there may be a few others part of that initial team that get to what we call preliminary examination, look at the samples, characterize them, make sure we have them cataloged, and then they'll be available as soon as possible for the entire world to request samples and to look at in their own individual laboratories.
I mean, how would they keep quiet if they found a six-legged creature in the soil sample? They pour it out on the table and like, you're not allowed to tell anyone because this has to be documented and researched. I mean, how can you keep that a secret?
I will tell you that if something like that were found, as soon as there was corroborating evidence, not just the one scientist, right? There has to be multiple people look at it, we would not keep things secret. We try to make our findings public as soon as possible. So I feel certain that if there's something there, that would be a pretty big story.
100%. Now, Brian, you wanted to ask a question, so you can unmute and ask your question. Sure, go ahead.
So I wanted to ask if you thought that that space debris mitigation would be a necessary step to actually really integrating and inhabiting Mars and the moon to humans. And I asked because is it important to have, you know, a clear path without having to dodge debris, satellites, and asteroids? And I'm also presenting about that at the Humans to Mars conference, which you also talked about slightly, and I'm excited to see you there in about a month.
Yeah, I hope to see you there too, Brian. I will be there at least one day. I don't think I can be there the whole time, but hopefully I will see you there. So space debris is a really important question, Brian, and certainly something that we're now realizing around Earth can be a real challenge. There's a lot of old spacecraft and sometimes pieces of old spacecraft that are orbiting the Earth, and we try and keep track and track every single piece of debris that we know of that's big enough that we can track. We follow those so that we know where they are, so that we can adjust our spacecraft that are orbiting Earth to avoid hitting those things. Because sometimes, even though they might be small, if you hit them going really, really fast, it's very dangerous for the spacecraft. So right now at the Moon and Mars, there's not a whole lot of activity there yet, but we definitely need to be thinking ahead and being responsible in how we, where the spacecraft are and how we track where they are and how we, what we call dispose of the spacecraft, right? At their end of life, making sure that there's a controlled disposal, or that we know when and where and how that's going to happen so that we can protect other spacecraft in the future. So I think if that's, an area that you're interested in the future, that is going to be a very, very important topic at the Moon, and then hopefully at Mars too. Right now, like I said, there's already a pretty good sized fleet at Mars, and with many more countries and private companies wanting to go to Mars, it's going to get busy there too.
So it's a never-ending story. In fact, it's only in its infancy, because, the more probes you put around a planet, the more satellites you put around it. I mean, it's just going to grow more space debris all over the place.
Yeah.
Sure. Well, now the big question is, we've got Jenny and Percy. Is that correct? Jenny and Percy, they are running around checking out what's going out in Mars, but they're not the only missions we've got planned for the next few years. What else is in store for us?
Well, let's see. Let's talk about Jupiter for a moment. I don't think we've talked about Jupiter yet.
We haven't.
So right now, in fact, everybody can mark their calendars and keep your eyes out, because this coming week, next Thursday, the European Space Agency is going to launch a mission that's going to Jupiter. It's going to Jupiter and its icy moons. It's going to explore the 3 icy moons, Callisto, Ganymede, and Europa. And so that mission is going to launch on Thursday. So that's exciting. And for my part, as NASA, we actually contributed to 3 of the big instruments on that mission. So we're very excited about that. And then NASA is going to be launching our own mission to Jupiter next October in 2024. And that mission is called Europa Clipper, and its whole purpose is to study Jupiter's moon, Europa. And the reason we're interested in Europa, we were talking about, looking for life beyond Earth. Well, Europa is a really interesting place because it's covered in an ice shell, and underneath the ice shell, there's a global ocean of salty water, an ocean, similar to our ocean, very briny, salty water. And so we originally were thinking about life could only exist, on an Earth-like planet that's just the right distance away from the sun, where water can be stable on the surface. It's not too hot, not too cold, kind of a Goldilocks story. And then we realized that beneath that icy core of Europa was this thick ocean that probably has hydrothermal vents and volcanoes underneath the base of the ocean. You can imagine as Europa goes around Jupiter, it gets stretched and pulled and stretched and pulled, and like tidal stresses that might drive thermal things like these hydrothermal vents. So you could have thermal energy, nutrient recycling, water, everything you need for life in that ocean. So wouldn't that be cool if there was actually some type of life existing in that ocean on Europa. So part of the goal of the Europa Clipper mission is to map out that ice shell, understand how thick it is, understand what it's made of, look at the dark spots on the surface and understand what makes up those dark spots. Are they organic materials? Did they come from the interior? Where did it come from? Look for possible geysers where material might be spewing out from that ocean out onto the surface. Measure how salty the water is, measure how deep the ocean is. Help us better understand if we wanted to go there and actually look for life in the ocean, what do we need to know before we go?
Now that is a serious step forward, because finding a fossilized insect or some kind of creature is one thing, but finding a living creature is a whole new ballgame.
Yeah.
Wow.
Yeah. And I think Europa is probably one of the most exciting places in our solar system right now for thinking about where life might exist today.
And how long does it take to get there?
So let's see, the ESA mission, the European Space Agency's JUICE mission is going to launch this week in 2023. It arrives in 2031. So it's going to take 8 years. The NASA mission, Europa Clipper, launches next year in 2024 and arrives in 2030. So it actually gets there a little faster.
Wow.
So 6 years. So it's because of different size rockets and different trajectories. It's just kind of how the physics works. But they'll both be there in about 2030, 2031, and begin their tour of exploring that system.
100%. Now, Jamie, you had a question. Jamie, you want to ask your question?
Can you tell me the names of the 3 moons on Jupiter?
The 3 moons that JUICE is going to explore are called Ganymede, Callisto, and Europa. So those are the icy moons that JUICE is going to explore. If you want to look up another interesting moon, I have to give an advertisement for Io, or Io sometimes pronounced. That is the volcanic moon of Jupiter. It's the closest in, and it gets, again, that tidal pulling from orbiting around Jupiter, and it's the most active volcanic body in our solar system, more active than Earth.
People have said that, why are we looking to go live on Mars when we could go live on one of the moons of Jupiter?
Ooh, that would be hard. It's really, really, really cold out there. Very cold. Yeah, I think that would be a challenge.
More challenging than Mars.
More challenging than Mars. Mars is
Wow.
closer. Mars is closer. We're already, trying to think how we're going to get astronauts there and get them back safely. You could imagine a long trip out to Europa and a long trip back. That's a long way to go. So hopefully we can do Mars first.
What do you think we should be looking at in the next 10 years? I mean, I know that from a space point of view, Mars is definitely on our radar. The moon is happening. It's all exciting. We're checking out Jupiter, and James Webb Telescope is producing the most magnificent images, and recently the one of Uranus with the rings around, absolutely beautiful. What can we expect in the next 10 years?
So I'm glad you mentioned the James Webb image. I hope everybody has seen it. If you haven't seen it, go find it. The James Webb image of Uranus, where you can see Uranus is such an interesting place. You know how Earth rotates around its axis like this and it goes around the sun, like this? Uranus rotates like this, completely on its side. So when you see the image of Uranus, you can see all its rings going around. It's amazing. And you can see several of the moons around there. It's spectacular. So actually, Uranus is one of the next big destinations for us. In fact, it's probably the next high priority big mission that we're going to send. After Europa Clipper and after the Mars samples are on their way back, the next big mission we want to do is to go out and visit Uranus, because that is probably one of the least studied planets in our solar system, Uranus and Neptune. So We have some data from Voyager flybys and a couple images from Hubble and now from James Webb and from the Kepler spacecraft, but we really don't know a whole lot about these, what we call the ice giants, Uranus and Neptune. And we actually, when we look at exoplanets around other star systems, a lot of those planets appear to be similar to Uranus and Neptune. And so we really need to understand them better if we want to understand exoplanetary systems.
Okay. Sean, you had a question.
Yes. So do you use websites like JMars and Astrometrica to find places to land on the moon and Mars?
That's a really good question. I will tell you that as a scientist myself, when I was still able to do science research, I use JMars all the time. It's a fantastic tool. And there's lots of tools like JMars out there that the scientists use in addition to JMars to do exactly what you're saying, to do their science research and then to say, oh, this would be a great place to land. When we were picking the landing sites for Perseverance, we use those kind of tools to look at all of the data and understand all the reasons why you would want to go to this site versus that site. So yeah, those are great tools.
And one more thing I'd like to mention is with I was using Astrometrica in Astronova school, and I found 15 asteroids so far.
Oh, fantastic. Oh, you know, that's something we haven't talked about is asteroids. Yeah, asteroid. Yeah.
So I might bring it up.
Yeah, that's great. Did anybody see the DART impact last fall when we for the first time moved an asteroid? That was cool.
But now the implications of doing that was quite important, because that was about averting future crisis when an asteroid is heading towards Earth. We now know we've measured the impact of the crater of the asteroid, but do we know how much off the path it went?
We do. In fact, we found out much faster than we expected. We thought it was going to take a long time. We thought it would take months. It actually only took a few weeks. But yes, we want to be, what we were doing with this mission was testing whether or not we could change the orbital path, the orbital period of an asteroid, so that if there was a dangerous asteroid headed towards Earth, and if we had enough time, we could do that, impact it and slow it down or speed it up so that when it crossed over Earth's path, we're out of the way. With this particular, with the DART mission, we were taking a small moon about the size of a high school football stadium that was rotating around a bigger asteroid, and its orbital period was 11 hours and 55 minutes before we hit it with the DART spacecraft. Afterward, we changed the period, shortened it by 33 minutes, which was pretty impressive for a small spacecraft hitting that. If you could imagine a vending machine, a Coke machine, Pepsi machine running into a football stadium full of rocks, and it changed its movement by 33 minutes. We had anticipated that we would be able to change that period by a few minutes up to a couple of tens of minutes. And so it wasn't totally outside the realm of what we expected, but it was at the very kind of far end of what we thought we could possibly achieve there, which I think is pretty spectacular.
I mean, what magnitude of impact would you need to really knock it off its path so that it does bypass Earth?
So here's the thing, the most important tool we have, more so than the size or mass of the spacecraft, is time. So what we really need to know is long enough in advance that something is coming, in which case it only takes a teeny tiny change that over time adds up, right? So that
the further away it is, the greater our advantage, because only a tiny fractional alteration of the path would mean in long term that it would actually go a long way around.
It adds up over time. So what we really want to do is find all those potentially hazardous asteroids so that we know, okay, this one is actually going to come, looks like it's on a collision course with Earth in 50 years. That's something we can do something about, that we can fix. So our next big mission for asteroids is called the Near Earth Object Surveyor. It's a telescope that we're hoping to launch in about the 2027 timeframe, that its whole goal is to look for those hazardous asteroids. It's going to night and day, it's going to be scanning the sky, looking for, just like, was it Sean that was saying about looking found for asteroids? The Near Earth Object Surveyor is going to be looking for those new asteroids, in particular, those asteroids that fly close by Earth, that are near, what we call near Earth objects. And it's going to be looking for those. We're going to track them, we're going to catalog them, and identify, hopefully, of the ones that we think are particularly dangerous to Earth. We want to identify about 2/3 of those within about 5 years, and hopefully 90% of that population within 10 years.
Okay, and Jamie, you had another question?
Yeah, I'm entering the competition to plant something on Mars, and I'm wondering if you have any ideas for something.
Oh, planting something on Mars. Yeah, it's a challenge, right? To get something to grow in what we think the Mars rocks are made of. We have a few meteorites on Earth that came from Mars. We have an idea what some of the rocks are made of on Mars. But it's hard, because one of the things we need to grow plants on Earth is what, the organic matter, that has turned into soil on Earth. So I think you're probably going to need some water. You're probably going to need some kind of organic matter in order to get things to grow. That's my guess. I don't know.
You do get sun on Mars?
You do get sun, so that's going to be important too.
But not much in the air department.
Not much no. It does have carbon dioxide, right, which is what the plants need, but not a lot of it. It's a very, very thin atmosphere.
So it's quite hostile, but I've seen people grow potatoes on Mars. It's old news already, if that's even true. How often do you watch movies and think to yourself, what were they thinking? How did they think they were going to get by with that? There's no ways that a rational scientific mind would even think that that is possible.
There are movies that I do that, yes, that I think are just a little bit beyond my realm of credibility. But there's a bunch out there that I think are entertaining and very fun to watch, and that have done a really conscientious job of trying to represent the science. They may have a couple places where they take liberties and go a little bit beyond, but I like to overlook that if on the book they're well done. And there's a handful of those that I really like.
Do they ever consult you?
I've not personally, but they definitely consult NASA. So I actually know, I probably shouldn't plug particular missions, but movies, but I know that the person who had my job before me was consulted on a certain Mars movie that included growing potatoes. And then we also had people from that are part of our NASA community and NASA scientists that were consulted for, the recent asteroid, or I guess it was a comet impact movie, the more recent movie. So yeah, we do get asked occasionally to help provide scientific input.
Do you think we're going to see humans on Mars within the next 20 years?
I sure hope so. I think we're getting there. I think that the Mars sample return mission that's going to bring back the samples Perseverance is collecting is going to give us an enormous amount of information that we need to help us more confidently put humans on Mars. Being able to launch from the surface of Mars, demonstrate we can do that, demonstrate we can safely bring back material from Mars, which a lot of people we still are uncertain about, being able to close off some of those things that are ultra risky, I think is going to help us get humans there. So there was a long time that we weren't sure we were even going to get rocks back off the surface of Mars, and we're moving that direction now. So I think we're going to get there.
It's quite exciting. I mean, if you think about how the space industry has changed in the last, if you go back 20 years and you look at what we've done, then you go back 10 years, then you have 5 years, just in 2 years. I think we've seen more rocket launches in 2 years than we've seen in the last 20. It's just been insane.
Absolutely true. Yeah, I think the interest is growing. Just the technology that's required is, we're now seeing so many more companies that have the technology and the capability. More people can launch, more people can fly their own spacecraft. It's, universities are flying their own small spacecraft. There's just so much capability and interest. It's definitely growing.
I mean, CubeSats is very big with a lot of the universities because they're able to obviously create all these wonderful things, and then they get to send their experiments up into space, and it's a wonderful learning tool, and obviously motivates them, and they want to get more involved in the space industry. And I can't remember the figures, but the financial value of the space industry has gone up in numbers that I would feel uncomfortable to even say, and that is testament to the fact that there's so much going on in the space world, and you never know where it's going to lead.
Absolutely.
So if you had to give any advice to young people in terms of getting into the STEM world, because I know that you didn't start off wanting to go into space, but serendipity led you there, what sort of advice would you give people to pursue a career like yours or to get into space?
The thing I always tell folks is to just follow your passion. Find the things that get you excited about working on them, or that really give you joy, and continue to follow that path. And just to keep in mind that, even being part of the world of space exploration, there's a lot of scientists and a lot of engineers, but there's a lot of other important jobs that help the whole endeavor happen. So it's not just the scientists and engineers that make it happen. STEM is important. I love science. I love math. Definitely encourage people, but follow what you're interested in. We have communication specialists, we have artists, we have animators, we have budget people, we have lawyers, we have everybody supports NASA and what we do. And so I definitely encourage STEM education, but I also encourage folks, if they're listening and you say, well, maybe STEM is not for me, there's still a way to be a part of the amazing things that we do.
Sure. Is there a bet on who the next person will be to step on the moon? Do you have like some sort of office pool there that everyone's putting money down on?
I'm not going to go there. I know we have a fabulous astronaut corps. They're all wonderful. We're very interested in seeing geology on the surface of the moon, and we're training the astronauts in order to be able to actually be astronaut geologists on the moon. So I just hope that whoever goes has a passion for helping us understand all the geology on the moon when we get there.
Absolutely. One final thing about Mars. We're obviously there. We've had a presence there for quite a few years, but sadly we've had to bid farewell to certain rovers that are sending these terrible messages to say, signing out. And I mean, it's very emotional. You've been involved in some of the missions. How does it feel when you know that the project has finally reached its end point, and this poor device is now, I mean, you've almost given it a what do they call it when you personify, when you, what is it?
Anthropomorphize.
Anthropomorphize, whatever. We do one of those things, and we give it a life and a presence, and then all of a sudden it's departing that planet, certainly not our planet. And I mean, how does that make you feel when you know that the mission is coming to a close on that particular thing?
It's hard. It's always hard with any mission. It's hard because, not only has the mission provided incredible science data and science results, but the human part of each one of those missions. Yes, we kind of give these missions their own human qualities. So that's hard in itself, but just knowing the number of people that have worked on these missions for years and years and years, and the amount of effort that they've put into making those missions successful, it's really hard to say goodbye to all of that. And we did just have to, I wouldn't say we said goodbye, we said good night to the InSight lander on Mars just recently in December. An awesome mission. It only operated about 4 years on Mars, but it did some incredible work. It detected over 1,300 Mars quakes on Mars, and from that we're able to learn about the interior of Mars, understand the size and the liquid state of the core. I mean, we learned so much, and yeah, it was a hardy soul. Worked really, really hard to stay alive and maximize the science on Mars. So it was hard.
True. Well, all I can say is that I think that the future is bright. We have a lot of young, talented people who are moving into the space world, and I think that they bring with them intellect, creativity, but more importantly, they have incredible role models like you who are inspiring them to obviously move in various directions. And on that note, we would like to thank you so much for giving up your time, your passion, your enthusiasm for space, and in particular Mars. We like the fact that you are a big fan of Mars. For those of you that are going to the Humans to Mars Summit from the 16th to the 18th of May, hopefully you will get to see Dr. Lori Glaze on one of the panels. And if you are there, go bump into her and say hello. She is a very friendly person. And for those of you that are not going to be there in person, I believe much of it will be streamed live. So if you go to exploremars.org, you should be able to find all the information on their website. And on that note, we'd like to bid you all farewell. And thank you so much, Lori, for joining us. And for those of you that joined us live on the live stream, and for those of you that joined us on social media, and of course, for those of you that are going to be watching this during the Humans to Mars Summit, because this will be played in the interlude, we hope that you enjoy this and that you are going to learn as much as we have today. And on that note, I'm going to end the live stream on YouTube. If I can find it, here we go. And the live stream is officially over. And let's see over here, our recording is going to end over here as well.